Welcome to our EECS 497 demo of our final application, Secretariat. Our application is a calendar event tracking app that is targeted at kind of a wide audience, working professionals, parents, college students, just so they can track tasks, projects, and events they may have going on. And what sets us apart from other kind of similar apps is that we have a predictive scheduler feature where kind of you can specify a date for a task, and then our application will suggest a good time to do that, and we'll get into that more later. But first, you can see here the basic calendar view of our application. You can see the current month and all tasks that you have on each given day. And at the top, there's the yearly, monthly, and daily view. So we can click on the year view here, and you can see kind of all the months in that year. And then if we click on one of those months, like February, for example, we can use the left and right kind of buttons near the top to go to the next or the previous month. So getting into some of the functionality, some of the other basic use cases of our app, if you click on a given day here, you can see we go straight to the daily view, and we have the single event here on this day. So we can edit this event, say we're going grocery shopping and maybe we wanted to eat, so we'll go in an hour. So we can change things like the title, the description, and most importantly, the time. So say we want to change this from 25th of April at 12 to like the 25th at like 1400, like 2 p.m. We can do that. It takes a second here. We can also change things like the color you see at the bottom. We can change it from a yellow to, I don't know, something like maybe a purple or a blue. And once we save those changes, you can see that the event is updated. I think we went to the next day here. I think it's on the 25th. Yeah, so there's our grocery shopping. It went from noon to 1400 hours, 2 o'clock. And similarly, we can delete events. So say we finished eating and we took so long that our friend told us that they would go grocery shopping for us. So if we click into the event again, we can go to the bottom and choose to delete the event. And you'll see now it's updated on the calendar and the event is no longer there. And then lastly, you can create events, and I will let Ray kind of get into more of that.
So by creating events, you can click on the top right corner, and there's two types of events you can create. The first is a standard event, which is at a set time, and you can, similar to editing, you can put the title, the event, and the from and the to, and you can choose the color when creating this event. So as you can see here, if we wanted to create an event for April 25th at 6 p.m. So that would be 1800 hours, and you want the event ends at, let's say, 10 p.m. And we can save the changes, and you'll see that the event will now pop up in the designated time slot. Another type of event that we can create makes use of our predictive scheduler. And under the event type, you just click the drop down and select task. And instead of a from and a to time, you will give a duration and a due date. So what this will do it will feed this information to our predictive scheduler, and it will suggest 3 different times. So if we put in 2 hours and put in this due date, you will see the 3 times that the predictive scheduler returns is 3 possible times where a user could do this specific task. And this would be very helpful if someone was very busy and wanted to schedule a homework assignment, or an artist needed to work on their art at a specific time, or we had a project manager that needs to find time for specific tasks. And if we save these changes, if we select one, and you'll see that the option will pop up right there.
All right, then aside from the predictive scheduler, we're also implemented some Google Calendar integration. So that means that on this left sidebar, you can see there's a sign-in option the user can press. So if they go ahead and click that, they should be able to see a pop-up window that shows up, and it'll show a couple of their Google accounts. And they can go ahead and just select one. And once they do, they'll get automatically signed in, and any of their Google Calendar info will go ahead and get integrated into our application. So for example, all these dark events that weren't there before came from the Google Calendar of this account. This is very useful because when creating events, sometimes you want to verify that those events don't happen to overlap with other events that might exist outside of this app. So it can just be useful for the user to have that information there so that when they're either planning or using the predictive scheduler, those events are also included inside of everything that is being processed. Should you decide that you no longer want to have the view of the Google Calendar events, you can just go ahead and press the sign out function and all the events will disappear. This will not delete any events from your actual Google Calendar. It simply removes them from our application while keeping the previous apps or previous events that were there still intact.
So the way our app works under the hood is that we utilize the Electron.js framework to create a desktop app, and then use the React JavaScript library and components for the different parts of the project. The way we broke our project up was that we have a parent app component and a daily calendar component, an event editor component, and a sidebar component. To make sure we were spending enough time on the core selling point of our project, we searched and found a pre-built React component calendar to utilize and then edit from there. Because we ended up utilizing a pre-built calendar, some of the usability wasn't what we, or some of the modifiability wasn't what we were expecting. So we had to make a different component for called an event editor component to be able to update the daily calendar events. And we did that by working with component state updates.
Our predictive scheduler uses an algorithm that we created that takes all the times slots in half-hour increments from the current time to the due date. And it will look through each day and find all those events that are scheduled for that specific day and remove all the time slots that collide. And in doing so, we get all the time slots that are available for the user to choose, and our scheduler chooses the best 3 time slots to send to the user. And out of these time slots, the user can choose whichever one works the best for him or for them.
In terms of the Google API, to get the Google Calendar integration working, we had to go ahead and get our application registered with the Google Cloud Platform. From there, we were able to acquire things like a client ID and an API key that we were able to use within our application, and that was able to establish that connection between the API and our app. So from there, that's essentially what allowed our app to be able to import any of the events that the user would have wanted to see inside of the calendar.
So onto some of the challenges we ran into. As mentioned previously, we chose to work with an existing calendar view library, and it had a lot of the UI features that we were looking for, but it didn't support a lot of the functionalities that we were looking for, which kind of forced us to make our own new components to be able to edit that component. This resulted in us having like React component state updates and date change issues, where we're having a lot of trouble making sure that when we created an event or edited an event, that once the user clicks save, that when they go back to the calendar, their what they wanted to do actually happened.
Additionally, we had a lot of time zone conversion issues, especially related to our predictive scheduler algorithm, because the way that JavaScript represents dates is actually different from the React input date. So we had to do some conversion between the local time zone and GMT time, which is what standard JavaScript dates are.
And the challenge with the predictive scheduler is that it was very open-ended, and there wasn't many algorithms that we could find that kind of represented the predictive scheduler and specifically what we wanted to do. So we were almost going in blind. And in doing so, it was very difficult to test because not only there were problems with parent-child communication, but there were also problems with if we had to test looking through every specific output and seeing if it was a valid output or not. And it took a lot of time on our part to actually make sure that our algorithm was functioning properly.
With the Google API, some of the difficulties just came with how many small details there were when it came to like registering our application with the Google Cloud Platform. There were just like a lot of different boxes that had to be checked and a lot of configuration that had to happen that was a little bit tricky to figure out because if something was wrong, it resulted in the API connection not being able to be established. Additionally, looking at any kind of like tutorials, oftentimes those would be fine-tuned to a very specific application with very specific settings. In order to get the Google API to work with that app. So it was sometimes that information could be applied fairly well to our application, but other times there would be like differences that wouldn't end up working. So just getting everything up and running and functioning correctly definitely took a lot of time, but in the end, it did seem to start working correctly.
And that wraps it up for our demonstration of our EECS 497 project, Secretariat. Thank you for watching.